Hey, Mr. Richards here. Today's 6th grade Unit 6 Lesson 4 Anchor Problems. In question 1, the following three diagrams represent the equation x plus 2 equals 6. Explain how you can use each one to find the value of x. If we look at the first one, what we have here is an x plus a 2 that, well, equals a 6. How can I find out the value of x? Well, if I were to remove this 2 from the situation and subtract the 2 from 6, that would get me a result of 4. And so x must equal 4. And sure enough, if I had 4 plus 2, that does equal 6. What about in the next diagram? Well, on this left side, what I see is an x plus a 2. On the right side, I see this thing equaling 6. So x plus 2 equals 6. Now, this is like a balance scale. So if you take something away from the left side, you have to take something away from the right side. And so if I take something away on the left, I have to take something away on the right. If I take something away on the left, I have to take something away on the right. And so now I have just the x equals 4. And so x is equal to 4. Same idea here with the hanger. So we have a tape diagram, a balance, and then this is called a hanger. Now, if you pictured a clothes hanger, if it's balanced like it is right here, the left side equals the right side. And so if I remove 1 from the left, I have to remove 1 from the right in order to keep it balanced. To find out the value of x, if I remove 1 more 1 from the left and 1 more 1 from the right, I get the fact that x is equal to 4. Now, algebraically, what is taking place here? If I have x plus 2 equals 6, our goal in solving equations is to find the value of the variable, in this case, the value of x. You'll hear a lot of talk about let's get the variable alone. Well, in order to do that, we need to move away everything on the same side as the variable, in this case, the plus 2. Well, what did we do with all these? We subtracted 2, we subtracted 2, we subtracted 2. Well, what's the opposite of addition? Subtraction. So instead of adding 2, if I subtract 2 from both sides of this equation, x is left. This plus 2 minus 2 cancels out. It's 0, and that's what we kind of want here. X is going to equal 6 minus 2, which is 4. So we can use the opposite operation to help us solve. Now, how can you solve the equation m plus 3 and 6/10 equals 9 and 2/10 without using a diagram? Let me rewrite that. M plus 3 and 6/10 equals 9 and 2/10. Now, again, the goal is to get the variable alone, and our variable is here with the m. What do I need to move away this plus 3 and 6/10? Well, the opposite of adding 3 and 6/10 is subtracting 3 and 6/10. And if I subtract 3 and 6/10 from the left side, in order for this equation to remain balanced, I need to subtract 3 and 6/10 from the right side. What we're left with then, just the m, as this plus 3 and 6/10 minus 3 and 6/10 is 0, so it cancels out. And that's going to equal 5 and 6/10. Now, with any equation, you can go back and check. And so if we look at this x plus 2 equals 6 idea, if we restart with x plus 2 equals 6, if I put in 4 for the x, I should have the left side equaling the right side. And 4 plus 2 is 6, so 6 equals 6. So that x equals 4 is a valid solution. Same thing even if we have decimals. If we check this one, the m plus 3 and 6/10 equals 9 and 2/10, and I put 5 and 6/10 in for m, the left side needs to equal the right side for 5 and 6/10 to be true, and sure enough, 9 and 2/10 is what these two add up to be, is equal to 9 and 2/10, so m equals 5 and 6/10 is a valid, good solution. Problem 2. Draw a tape diagram to represent the equation d minus 5 equals 7, then use it to find the value of d. All right. Well, the tape diagram is basically drawing our rectangle here. And I'm not too caught up on tape diagrams. We have this d, and then we'll call it a minus 5 or a negative 5. And it's going to represent together 7. And so I'm going to rewrite algebraically here as well. D minus 5 equals 7. Now, to find this value of d, whatever this d is, minus the 5 is 7. Now, similar to the adding equation, if I remove this minus 5, I would do so by adding 5. So if I add 5 to this 7, that's going to be 12. In other words, d has to equal 12, so that 12 minus 5 is equal to 7. Now if we come back over to this algebraic way, our goal, again, is to solve for the variable, the d, and this is a minus 5. So how do I get rid of a minus 5? Add 5. So when we add 5 to both sides of this equation, on the left side of the equation, we're left with d. This minus 5 plus 5 cancels out because that's just 0. And 7 plus 5 is 12. So d equals 12. So how would we solve p minus 3/4 equals 8 without using a diagram? Well, if our goal is to solve for the p, what's the opposite of minus 3/4? Adding 3/4. So if we add 3/4 to both sides of this equation, the minus 3/4 plus 3/4 cancels out, that's 0. On the left side of the equation, we're left with p equals 8 3/4. And just like the equations in problem 1, we can always check our solutions. And d minus 5 equals 7, we're saying d is equal to 12. So if I put 12 in for d, 12 minus 5 needs to equal 7, and sure enough, 7 equals 7, so d equals 12 is correct. Same thing here. If I rewrite my p minus 3/4 equals 8, I put 8 3/4 in for p. 8 3/4 minus 3/4 is 8. 8 equals 8. That's great. And p equals 8 3/4 is the solution. Problem 3. At the grocery store, Martin uses some coupons and saves $5.75 off his total bill. His new bill comes to $21.36. Let X represent the amount of Martin's grocery bill before using the coupons. Write and solve an equation to find the amount of Martin's bill before using coupons. So before we put the numbers in, basically I hear that we have a bill, I'm just a bill, before coupons. And then we're subtracting away the coupons, and we get the new bill. So it's saying in our question, let X represent the amount of Martin's groceries before using the coupons. That goes here, X. Minus the amount of coupons is $5.75 equals his new bill of $21.36. So there's our equation. the bill before coupons, X, minus the $5.75 in coupons is going to equal $21.36. So if we add $5.75 to both sides of the equation here, negative 575 plus 575 is 0, so that cancels out. We're left with just the X on the left side equals, and we add this up, $27.11. So $27.11 was the bill before the coupons. Now that's the last example. But let's review what we've been doing so far to solve addition and subtraction equations. If I have something like X plus 8 equals negative 12. Let's throw some negatives in here for some fun. That means something plus 8 has to equal negative 12. And I know for some people it's easier to visualize these things as a left side, right side type of thing. And we want to be able to get this variable alone. And so this is a positive 8, a plus 8. So I need to subtract 8 in order to get the X alone. But whatever we do on the left side of the equation, we have to do on the right side of the equation. That way, the plus 8 minus 8 cancels. We're left with X equals negative 12 minus 8 is negative 20. And as I've mentioned in a couple of examples, you can always go back and check your work. You start off by rewriting the original equation, X plus 8 equals negative 12. And then you put back in your solution. So in this case, negative 20 plus 8 would need to equal negative 12. Well, negative 20 plus 8 is negative 12. Left side equals right side, so X equals 20 is our solution for this equation. Now, what about when the variable's not on the left side? When we have something like 15 equals X minus 20. That means 15 is equal to something minus 20. Well, our variable's now on the left side. And for some of us, if it helps to draw a little dotted line to separate the left side from the right side so we can visually see, then do that. Now we need to move this minus 20. And the way we're going to do that is by taking the opposite operation. The opposite of subtraction is addition. So we're going to add 20 to the right side. And if we add 20 to the right side of the equation, we have to add 20 to the left side. So that way on the left side, we're left with 35 equals X. And on the right side, again, minus 20 plus 20 canceled. So we're just left with X equals 35. In order to check that, go back to your original equation, 15 equals X minus 20. Substitute in for X, your answer, which in this case was 35. And sure enough, on the left side, 15 equals 35 minus 20 is 15. And so as we start to learn how to solve equations, make sure that you're identifying left side, right side, figure out where your variable is, and you want to work to get your variable alone. You're using opposite operations in order to do that. So this was a plus 8. To get it, the X alone, we subtracted 8. This was a minus 20. To get the X alone, we added 20. And you always have the check steps to go back to make sure you're right. If you use the check steps effectively, you'll get every single equation question correct. You start off by rewriting the equation, you put in your solution, and if the left side equals the right side, you're good to go. Just a bad check step real quick. Say you got, I don't know, say you accidentally subtracted 20 and got negative 5 for X in this last equation. What if you said X equals negative 5? Well, then you would put in 15 equals X minus 20. 15 equals negative 5 minus 20. you get 15 equals negative 25. Well, clearly that's not true. 15 is not equal to negative 25. So you would know that x equals negative 5 is not a possible answer. So you would go back to your question and see if you can solve it a different way to get to the correct answer. So that is it for this anchor problems. Good luck.